In this lecture, I am going to walk through dynamic models, and I'm going to do that by looking at an Excel demonstration, and then we will look at some of the equations that underlie the process at present in a dynamic model. So the way I want to illustrate the impact of a dynamic model is by actually looking at what happens when we play around with different numbers in an example dynamic model. What I've set up here is a model of GDP where GDP is equal to a constant plus the previous year's GDP times our parameter gamma, which is our persistence parameter. And X is also going to influence GDP, and that's what we're going to be interested in. But the difference here is we have this persistence parameter gamma that is going to be influencing how exactly X impacts GDP. So how I've set it up now is we're in what we could call a steady state. With nothing changing, GDP is going to be at 1,000. And so in 1999 and 2000 and 2001, the X that we're going to be thinking about is tax rate, just for an example, and it's related to GDP directly by this -2 coefficient, just picking numbers out of the air here. What I want to look at is how current and future GDP are impacted when we change this X variable. So we're going to lower the tax rate from 20, which it has been and was forecast to be, down to 15. What we can see is that mathematically, with a change in that 5 of X, the impact, the hit on GDP, the increase actually, because it was a decrease in the tax rate, was 10. So it jumps up by 10. And so GDP goes up in 2001 to 1,010. However, this column is last year's GDP. That's what's in this formula right here. And for 2002, even though the tax rate is returning back to 20, back to its original level, we now have a different previous year GDP. And through that mechanism, GDP is actually going to be higher than it originally was, than the 1,000 that we started. So if we did the math here, we would find that the GDP was 1,010 in 2001. Due to the persistence, it's 1,009. I've set the persistence level here to be 0.9, meaning that 90% of GDP stays around, and other factors determine the rest of it. And we can see that total impact decreasing. Right? So on the graph, you can see that GDP jumps up, and then that impact slowly dissipates. Now the speed at which this dissipates is going to depend on gamma. If we had a much lower parameter, right, then it dissipates much more quickly. First the impact was 10, then only 5 is still around, then 2.5, it's dropping by half in this example every year. Right. But in both of these examples, with the 0.9 and with the 0.5, in both of these examples, eventually that effect will be completely gone. Now let's talk about that was a temporary change in the tax. It went down to 15 and back up. Let's talk about what happens if instead we have a permanent change. So instead of just changing the tax for 1 year, we change the tax forever. We lower it to 15. We can see that we have a total impact of first of 10, and then of 19, then 27. And the marginal impact, the additional growth in GDP happening from this permanent change in the tax rate is changing. It's decreasing. So first we got the full 10. Here we still increased. We got an increase of 9. And now this is 8.1, 7.29, etc. So we're increasing at a decreasing rate, and we could extend this out and see that as time goes on, we will hit a new steady state, and that new steady state will be 1,100. Now let's quickly talk through the mathematics of that example. So we have our equation here, GDP equals a constant plus gamma last year's GDP and beta 1x, which is what we are interested in and focusing on. And for that example, it was the tax rate. Now, what we're going to do is change x by some amount. In that particular time, and what we were looking at is how that change in our time right now, in our example it was 2001, propagates in future years. So let's say it's a one-time change. Right, so what we've done is we've increased the GDP in time t by beta 1 times our change in our tax rate. But this is going to show up in our future equations. So GDP next year is beta 0 plus gamma GDP in the previous year. And we're talking about a one-time change again. We're back to just looking at that. So we're going to write our x t without the change. Now this is changing. It's changing by this factor, beta 1 times the change in x. And so the change in GDP in our future year is going to be gamma. Now that was the 0.9 at first, and then we looked at the 0.5 version, times our beta, times our change in 1. We were looking at a change in 5. Oftentimes we're interested in what the impact of a 1 unit change would be. I will just leave it as our change in that period. We could do this all day. We could look at the change in time period 2. The same sort of logic would hold. We would plug in how did this change our previous GDP for, this is 2001, 2002, 2003. How does that impact in that way? And in general, the change in GDP, we're going to say S years out, because T is already taken here, is going to be, every time we're going to be multiplying that impact by gamma. It's going to fade in that way. So it's simply going to be gamma to the S. So as S goes to infinity, our impact will go to 0, because this will go to 0 if this is less than 1. We'll get to that next lecture. But we could calculate the impact of a change happening in a particular time period. We could say, what is that impact in S future time periods? Now we're going to do a similar exercise, but instead of looking at a one time period change, we're going to look at if this change is permanent. So it not only is changed in 2001, but also changed in 2002, in 2003, in 2004, etc. So let's think through what the impact will be in the next time period. GDP in the time period immediately following. So if this is 2001, this is 2002. It might be helpful for me to use actual years. I'm going to, for simplicity, drop the constant terms because that's not going to be what we're focusing on. So we're going to call this x prime. And our question is, how is this differing from the original? Well, we can see that it's going to differ beta 1 times x. That's going to stick around. However, the GDP in 2000 also had that. It had a beta 1 times our change in x. So there are two sources of impact here. There's the impact from persistence, and there's the impact from x being different. So the total difference, the change in our 2002 GDP, is going to be the sum of these two. If we did for 2003, we would have a very similar setup. Still gamma times 2002. Plus beta times our new x. We have again the direct impact. Beta times change in x, and our indirect impact, which is how did GDP in 2002 change, which is gamma times gamma beta 1 delta x, beta 1, delta x. So we have a gamma squared, gamma beta, plus beta 1. So any year that's s away from our GDP, we can characterize the change in our steady state GDP versus what it used to be as the sum of impacts. The direct impact from the change in t that year is going to be beta 1 times, the change in x that year. But we're also going to have that one from the previous, and the one from 2 years ago, and the one from 3 years ago, and the one from 4 years ago. So we can think about the impact on future GDP as being the sum of all the propagated impacts. Now, what we're actually interested in is what happens in the long term. What the long term in this sense means is what happens as we go out to infinity. What is the new place that we are getting to? And it turns out mathematically this infinite sum is just going to be beta 1 times our change in x, which typically we think of as just being 1. What's the impact of a 1 unit change in x? But in our example, I think we did a 5 unit change. And this sum will be 1 minus gamma. That's how we calculated that 1,100 on the demonstration that was shown before this. It was 2 times -5, -2 times -5, divided by 1 minus gamma. So the important difference we have here in our dynamic models, our models where we have a lagged y variable included, is that we have both a short-run impact, meaning the immediate impact, contemporaneous, happening that particular time period, and we have a long-run impact, which as long as gamma is less than 1, will fade to 0. But if we're talking about not a one-time change but a permanent change, then things look different. We have a short run and a long-term impact. That is what I want you to take away from this unit, this chapter, in this particular talking about dynamic models. And I do want you to be able to potentially calculate a long-term impact. I hope you're doing well, and I hope to talk to you soon.